Alright, so in this video we're going to actually program this conveyor system so that basically when a small box goes through, it will pass through, but a tall box, based upon this photo I will, if it comes through, then it will push it to this next conveyor. Just to keep that in mind, we're going to be doing this from scratch, and we're going to be using structured text this time. So also I'll talk about the things that need to be in play when you're using Machine Simulator. Again, this is Easy PLC's Machine Simulator. So you need to have it on the same computer that you have the actual Rockwell software on, or let's just say Siemens, or whatever you're using as your software, programming software. You need to have it installed on that actual computer. There's no way to connect it externally. Right, if you have it on your host computer or you have it on a different computer and you want to try to talk to the other computer, there's no way to do that. Just know that you need to go ahead and have it on the same computer. I use the thumb drive, again, so that I can transfer the license to wherever I want to, but that's completely up to you what you get, and I just want to make sure that was a common knowledge. Now let's get back to programming, and let's talk about the programming. So I have no programs in here. I have no logic in here right now. Okay, I am online. I am using a simulator, right, or emulator I should say. Slot 4 of my emulator right here, and so that keeps in mind, you can use a regular processor or a basically a emulator processor if you choose to. So real quick, I'm gonna double click right here and add my JSR to link my conveyor system routine down here. So I'm going to do the JSR, link it down here. Now I have that in there, and now this system will be scanning now. So it's in the scanning process. So the conveyor system is in scanning process. So that's all we need to do on the main routine. As far as this goes, we can go ahead and start writing logic. Now I don't have any tags in here, but I do have the tags already loaded in my OPC, so that I need to go ahead and use those same style tags. So what I'm going to do is just say if start PB, and I don't have this as a tag yet, so keep in mind I have to make this as a tag. Make new tag, and then it's not going to be a dent, it's going to be a bool. Depends on what you set your default is, on what your data type is going to come in as. So now we have that as a tag. So if start button, then and not stop PB. So we'll go ahead and add that in there as a new tag. Again, change the data type, bool. So if the start button is pushed and the stop button is not pushed, then we want to say system active equals 1. Else system system active equals 0. And we end our if, and we got to make the tag right here. So again, this is a bool, and we need to end our statement. So therefore we have the things that are corresponding right here. You can't see this, so if you wanted to test this real quick, you could say 1 you can see that it's active. And then you could say, well, if this is a 1, then it's not active. Okay, so keep in mind. Now, what about if this is a 1 and for some reason the start button is not maintained, it's just a momentary, then it's not gonna seal itself in. So basically the way you would go about doing that is, like, say if the start button was momentary, which I believe our start button is momentary. Let's look at this real quick. Start button, yeah, it's momentary. So the way we need to seal this in, if it's momentary, let's just go ahead and say if start button pressed, if start button is pressed. So let's change the statement. Okay, so let's say instead of else 0, we'll just say end if right here. So close the statement, end if, and then we'll say another statement that says if stop PB and not start PB, then system active will equal 0, and then we'll close the end if. We'll end if and close that, and now we can actually test this and see how it works. So now let's just say right here, we come up here, we do a 1, put that as 0, so it's a momentary, the active is still on. And then in this case, if let's just say we hit a stop button, it's going to write it to a 0, and again, that's momentary. So you got to be mindful when you're writing structured text on how things are operating. If you're using a momentary or a maintain button, that's just basically the gist of that, right? You know, you just have to be mindful of it. All right, so we have our start, and we can say if system, let's just say system active, then we want the, let's say we want the actual conveyor system to start. So conveyor 3 reverse is going to be the name. Oh, put the wrong thing. So let me go ahead and make that tag. That's going to be a bool. This is going to run our conveyor, and we'll just say if system active is running, if system active is on, then we want to go ahead and I'll put this to 1. Close the statement, or actually we can say else on this one, because it's not going to be it's not going to be a momentary thing. It's going to be on all the time, so it's going to be more like a maintain situation. So then we can do an else. So then we'll say conveyor 3, then we'll issue that to a 0, then we'll end. Actually, what else do we need to do while this is running? What we need to do, well, we need to do our light buttons. So if the stop button is pressed, or the stop button is pressed, we need to do our light buttons. We'll go back and add those up top. But let's end this if, and let's close that out. Okay, so what we need to do up here, then system or actually we need light. So light, this is going to be the start light, so the light on the push button. And we'll make that tag. Again, it's a Boolean, so keep that in mind. We want to write that to a value. And if you write it to a value, you have to unwrite it to a value, right? So just keep that in mind. So there's two things we want to do is we want a system active on, and the start light's going to cut on as well. And then obviously with the counter side to that being down here, we want to have start light off, because if it's off, actually if the start button is not pressed, but let's just do completely separate logic for that, because what I want to do is say if the start button is, if the start button is on, if you push the start button, I just want to cut the light on while you're pushing it instead of keeping it on the whole time. So let's just write that a little bit different. So let's keep these the way they were, and then what we'll do is add a second if. So if, let's put this where it belongs, so let's put it right after this. So we'll say if start PB, and then what we'll do is we'll say then, I like to capitalize my thens, so then the start light will be equal to 1, else start light equal to 0. And then we'll obviously end if, and make sure you put the proper end brackets. So right now what's going to happen is if I push the start button, the start button light is going to come on. Okay, so I'm going to have my light turn on because it's at a value of 1. I'm going to have my system active and my actual conveyor run bit. So now if I drop my start, okay, the light cuts off, but the system active bit stays on. So if we hit the stop button, then my conveyor stops. Okay, so that's pretty simple logic, right? As far as the way that goes. So let's look at the way, what else do we need to do here? Okay, so we need to have the pusher come out when it senses a bigger box. So if this photo eye right here, this is down here, if that photo eye is on, which we're going to call that PE1, if that photo eye cuts on, we're going to make the box pusher come out. Okay, so let's go ahead and do that. Let's go ahead and add that in here. So if, and you can write this in many different things. Okay, you don't have to write it if then else statements. I'm just showing you an instance of this, so just please don't hold yourself to just doing it this way. So if PE1, and yes, I need to make this tag, so we'll keep that as a Boolean. If PE1, then we want to have, this is called the pusher advance spell my stuff right. Okay, pusher advance. I need to make the tag because again this is a brand new file. So let's bool make that file, then oh wait, no, okay, so then write a value of 1. Close it off and then say, well we need to do this too, and not, there's an indicator on the pusher, so we need to actually add that in the system. So let me go ahead and click. So, and what we need to do, so again, there's a box pusher indicator. So we'll say pusher advanced, spell advanced right, advance, and then I called it END or IND, just for abbreviate the indicator. And again, the only reason I'm making my tags like this is because I already have my OPC done. So if not, then do that. Then we can say else. Then pusher advance 0. Close that out and end the if. So I believe we pretty much got this situation done, where we can actually see if we can't run it. We may have some things we need to correct, but as far as that goes, that's pretty simple. So let's go ahead and get our RS links and go to OPC DDE/OPC, and what we'll do is add a new one. Okay, I'm going to call this Conveyor 2. Come over here, point that to where my actual conveyor is. This is the actual processor is, and I'm gonna hit apply. Now what that's going to do is it's going to create an OPC. Okay, so this is creating the OPC inside of RS links. You have to do that first, or you're not going to be able to, make the connection. So right now it thinks that the connection is made, but it's really not. So I'm just going to restart this. Okay, and that way it will do that. And then let's come over here, shrink this back down so it's a easier to see type situation, so we can see the logic as well. At least we can see these two together. And then what I'm going to do is load my driver in. So OPC driver conveyor 2. That loads it in. If you're curious on how that looks, you just add in each thing that you have, like your outputs. Outputs would be things like start light, stop light, the pusher, the conveyor advance. The inputs would be right here: stop PB, start PB, the PE1, the emergency stop. We didn't put the emergency stop in our stuff, so just keep that in mind. I'm just doing this as simple as possible right now, just to kind of show you. Just because it's in there doesn't mean you have to use it. So what we'll do is we'll come over here and start the system, and let's see if our logic works. So we hit the start button. You notice the light only comes on when I push it. We have one box coming down. So we have one box coming down that's going to go straight past the pusher, because it's not going to make the photo out, right? And then the next box is tall enough so it should make the pusher, and then we want to have the pusher push it to the next conveyor. So these tall boxes will get pushed because, again, if we shrink this down just a little bit, what's happening, you can see the logic down here. PE1 and the pusher not advanced, then it advances the pusher. So you can see how that works, right? Now here's this little box that's going to go through, and it's not going to make the PE1. So in that case, it's going to let it go past the actual pusher. So you want the small boxes to go straight through, and you want the big boxes to be pushed onto the next conveyor. And then we can stop this whole situation right here just by hitting the stop button. And we can start it back by hitting the start button. Again, we did not put our e-stop or emergency stop in there, so as far as that goes, that's not in play right now. But it's as simple as this couple little if then else statements that I actually put in to make this conveyor system work. Now when you're doing a conveyor system, obviously the most common thing you're going to be using is going to be ladder logic. I was just showing an instance of you can do this in structured text. So with that said, hopefully you learned a lot from this video, and I apologize for how long it ran, but sometimes when we're doing stuff, you know, and having it detailed, you know, it's really good to kind of pass on as much information as you can. So hopefully you enjoyed the video, and we'll see you guys on the next one.